So Wojtek from Poland, and you're going to introduce and present the next generation of digital twin simulation platform for agriculture, isn't it?
Yes,
yeah,
exactly.
Super. So I give you the floor.
Okay, thank you very much. My name is Wojciech. I'm a product director at Robotec.ai, and today I will present RoSi, our core product that is next generation digital twin simulation platform, in this case applied for agriculture, but we are not only working for agriculture. Okay, so I will start with introducing our company. We are a deep tech company founded in 2019. We are based in Warsaw in Poland. And we are involved in multiple open source projects. And on top of our open source activities in ROS2, open source game engines, or open source LiDAR simulations, we built our product that is called RoSi. And it is applied for different industries for cost-effective and safe application, like development of automation solutions. All right, but just to begin with, I think a quite important question: why do we need simulations? For any one of you familiar with development of robotic software, I believe it's quite obvious that it's impossible to test every change of the software in the real world. It's just impossible to deploy every software every time we change something, to deploy it on the real robot and retest. That's why we need simulation, or at least recorded data. So that's the typical application of our solution, to provide robotic software or end user to have software in the loop or hardware in the loop validation of robotic software, just to make it faster, easier, and safer to test and to deploy, to deliver automation solutions to the market. Then when we have robotic software ready, we can run optimization or validation of systems that we want to deploy in our sites. That's usually applicable in highly automated environments like warehouses or underground mines. Okay, so just going back to our product, we created our product and we wanted to make it useful for confined areas automation. So we started with mining, with underground mining mostly, when we did a lot of projects from optimization of autonomous mining fleets. Then we expanded to warehouse logistics. And then at the end, like last year, we started working with agriculture OEMs. Okay, here we have a short video
introducing RoSi,
showing
the next generation digital twin simulation platform, offering high-performance simulations via proprietary ray tracing library and CUDA-enabled GPU, synthetic data generation to accelerate perception model training and validation, open platform and seamless integration with external software.
Okay, now we have no voice. So basically we are showing different applications here, and for example, here we show that we can scale up and run multiple scenarios, like I said before, from different domains. And what we show here is that on top of that, we provide quite simple graphical user interface that we want our simulation to be useful for everyone, that everyone can use it, and you don't need to be like software engineer or simulation engineer to run simulations. So it's accessible to everyone. So we want to make it as simple as possible to define and run different scenarios for your automation software. Okay, so here is like a very, very simple and high-level block diagram showing what you can define as an input. So because we have a simulation, and then you can change different aspects of your simulation to generate a lot of data to test different scenarios. So here we have, on the left, we have parameters that you can change. So we can test different machines, different vehicles or robots. We have variety of sensors. Mostly we are focused on RGB cameras and LiDARs, but we also have GNSS with RTK, IMUs, ultra-wideband, and others. We have physics simulation, of course, as part of our engine. We use a game engine, so we take some of the things from the game engine directly. We have different vegetation, different trees, different crops, and we are able to apply changes to the environment. So different lighting conditions, day, night, rain, fog, snow, and so on, to just have more like data that differs a lot, to generate a lot of them to just test your software in different conditions. And then as an output, you can either calculate metrics for your software, like average velocities, how well it follows the path, and so on. You can generate synthetic data sets, so all the data that we generate from the sensors are automatically labeled. And the big value that you get is, of course, evaluation of your software or hardware. Okay, and just to repeat once again, our solution is designed to provide large-scale scenario-based software in the loop or hardware in the loop testing. And also, due to the very good performance of our sensor simulation, we're able to simulate multiple robots under test at the same time. This is an enabler for testing more complex systems than just one machine, like one tractor. We can test fleets at the same time. Okay, and let's go to the use cases. This is actually the real use cases that we work with agriculture OEMs. Unfortunately, I cannot share the name of the company, but this is like the easiest and the most common use case of the simulation. So we recreated the site of our customer. We have a 3D modeling team in-house that helped to create the digital copy of the test site. And then the customer integrated their software in the loop and integrated it in their CI/CD pipeline. So every change they make in the software is automatically tested in our simulation platform against a set of predefined scenarios. Second case, again for different OEM, is related purely to synthetic dataset generation. Again, we have a set of predefined scenarios. We run them with changing conditions, and we just store ROS bags with sensor data and synchronize the data annotations. So semantic segmentation, bounding boxes, and so on. And it's later used to train machine learning models using both real and synthetic data. Okay, and then the other use case that is, again, software in the loop, but it's more showing how to test cooperative robotics, so cooperation of different systems. So here we have two different systems integrated as software in the loop. One is vision-based inspection software on the drone that is flying around the field. And the other one is a tractor with a sprayer. So this is like testing of cooperative solution for selective spraying. So drone detects on which areas crops have some kind of disease, and this information is sent to the tractor for path planning and spraying algorithm, let's say. Okay, and here's the video showing this cooperative robotics use case. So we can see the drone is flying around and it's controlled by its own software, camera data. These are actually labeled crops, and then it sends the information to the tractor. And again, it's tested if it can follow the path and properly spray the areas that were detected by the drone. So like drone is assigning mission to the tractor. Okay, thanks.
Merci Wojtek pour cette présentation. Est-ce qu'il y a des questions dans la salle pour...
Thank you very much, Wojtek, for this presentation. Do we have any questions if you want to ask Wojtek, please do. Je vois une question là-bas. Très bien, merci.
Oui, n'hésitez pas à vous présenter, s'il vous plaît. I have a question.
Okay.
Actually, I have two questions. The first is, do you
also do simulations with real collected input data from LiDAR scans, like 3D model scenes?
Okay, I'm not sure if I understand your question properly, but we use real data to create 3D environments. So that's our typical flow, that if customer really wants to have a virtual copy of their environment, they just give us 3D scans, additionally some videos probably, and we recreate their environment. But this pipeline is not fully automated for customers now, so we get data from them and we help them creating this 3D environment.
And the second question is, with artificially generated 3D models, how do you create random scenarios, or how do you randomize, like, for example, trees or plants?
Okay, so one of the cases is that, for example, we generate a terrain shape based on recordings, and then we randomize, we have randomization methods for putting trees in slightly different places. Or we have real position of this tree here, and we can randomize it by putting it in a circle of, let's say, 0.5 meter to each side. So we have some randomization mechanism working together with real data.
Okay, thank you.
Thank you very much.
Et vous êtes? Ah, who am I? Yeah, I'm Patrick. I'm just here for interest, and mechanical engineer, and read a lot about robotics and AI, and like all the papers, not all the papers, but a lot of papers from Google DeepMind and ETH. Yeah, that's
okay. Nice. If you want to learn more, we have a booth here at the other side. You can just come by.
I will.
Perfect. Thanks.
Merci, Patrick. Is there any...
Thank you, Patrick. Thank you.
First of all, you can hear me, right?
Yeah, now it's fine.
Okay. So I have two questions. First of all, are you? Let's say I have in my vehicle I have a sensor, let's say an IMU, and I know the noise model, for example. Can I simulate that noise model?
Okay, off the shelf we provide some noise models for every sensor, but if you have something very specific, that's typically, like, we worked with one of the RGBD cameras manufacturer, and with them it was like they gave us a lot of data, and we modeled the noise specially for them. So it's also possible. We are a very flexible company, so we can work together on additional features. So it's
okay. My question was in regard to, once you have selected your hardware and you want to simulate it, you want it to be as similar to the real world as possible.
Yes.
So talking about LiDARs, RGB cameras, everything. So it's important to, as long as you can, model it as similar to reality as possible.
We have quite a big library of LiDARs that we take care to be as close to reality as possible. But for IMUs, I think we will have to work a bit together.
Okay. It was just an example.
Yeah, okay.
The other question was regarding the integration with ROS2. I think you mentioned ROS2. How is this integration? Is it similar to Gazebo, where you have Gazebo topics, Gazebo sim, I mean, and then there's kind of a bridge, or?
There is no bridge. We use O3DE engine. You can check it. It's open source, and also robotics integration part is open source. We actually work on it together with O3D Foundation. So the integration is done directly in the engine. So it's more performant than solution with bridge. But basically communication is done by ROS topics by default. That's our default communication.
So all data types in ROS2 are supported in the simulator?
Yeah, I mean, usually, for example, LiDAR, we just send point cloud 2 message from the simulator. You can subscribe to it and send back control messages, or on Ackermann steering or something like that.
And all the recorded data that you can then use to analyze or train models is also ROS format?
Yeah, by default, if you click the button, when you want to execute scenarios and you click a button that you want to record data, default format is ROS back. Okay. It's like ROS2 back, right?
Okay, thank you.
Thank you.
for simulating dynamics? Are there ways to define like plants in the simulator to define those kinematics, or are you relying on the physics simulator purely inside the game engine?
Currently, we use the one from the game engine.
Another question, and do not hesitate to introduce yourself.
Well, I introduced myself. I'm Andres. I'm a robotics engineer, so that's why I ask so many things about that. This question is quite specific. Do you support, or how much do you support simulating the contact with the ground for different type of wheels, tracks, and so on?
We're still working on it. I mean, so it's to some extent it's simulated. Of course, it's not super realistic. So I would say we are still working on it.
Okay, thank you.
Another question. Introduce yourself, please.
I'm Refin. I'm from the U.S. Are there ways of expressing conditional logic? Like we had earlier talk this morning of a hackathon on defining contact points for plants, and then you could score yourself based on how many stems you ran over or something like that, as well as the amount of coverage you made in a certain amount of time. Are there ways of customers expressing these kind of conditional game
okay, so
logic?
it's like related to metrics.
Yes.
To the outcome. Okay, we have a way to define metrics on the user side, but I'm not so sure. I need to think. I need to think about your use case, because
you had one about the quality of what you follow the path.
Yeah.
Is that like you subscribe to both the planner's published path,
yeah,
and then record the
actual
the ground truth, and then compare that?
Yeah.
And so it can be dynamic based on whatever scenario the planner was doing, not necessarily fixed to the world. Okay.
Yeah, that's. But you need to. About metrics, we provide a set of predefined metrics, metrics implementations, but if you need something custom, you need to write it on your own in the way you described, or we can support it, right?
Thank you.
Okay, last question. Thank you. And introduce yourself, please.
Hello, my name is Robotec.ai from Filippi, Polska. I have a question more about the kinematics of the, let's say, tractors that you are using, or the vehicles in general. Do you support, let's say, different models, or you are relying mostly on what is introduced by the game engine? And do you, if possible, to introduce some irregularities that are specific to certain models, or let's say it can be some, let's say, mechanical noise that is introduced in a certain vehicle? Or do you have some ways to actually like test the vehicle, extract some information that could be useful for you, and then create a model based on that?
Okay, by default we use vehicle dynamics from the game and provided by the game engine that we use, so O3D. But answering your second part of the question, we did something like that for one of the mining vehicle, that we got a lot of information, a lot of data recorded for one of the mining truck, let's say, and we were adjusting the model. There's still the model available in the engine, but we're adjusting it to make it as close to reality as possible.
Okay, thank you very much. Just Wojtek, can you just tell me where you are located on the where is your booth?
It's booth number 43, I believe. It's on the other side. It's on in the left row. You just continue straight, and it's on the right side.
So thank you very much, Wojtek, and we will welcome you on the booth for more questions.
Thank you very much.